Hello, Mrs. Torzilli here. We're going to talk about the function analysis relearning. So we're going to do a couple questions to help you practice and prepare for your relearning. Let's start with question 1. We're going to create a quadratic equation that has x-intercepts of -3 and +3 and goes through the point 0, -9. Okay, so question 1. We're going to create a quadratic equation. It has x-intercepts of -3 and 3 and goes through the point 0, -9. Okay, so there's a couple ways to do this. I'm going to first show you how to create this equation, quadratic equation in factored form, and then I'm going to show you how to create it in standard form. So first, let's start with factored form. Factored form is y equals a x minus p x minus q, where p and q are your intercepts. So this is p, and +3 is q. And all we really need to do is find a. So I'm going to replace all the letters with the actual numbers we know and solve for a. So we have, instead of y equals, we have -9 equals, a is what we're searching for. Our x is 0, minus p, which is -3. 0 again, minus q, which is +3. Now we just simplify and solve for a. -9 is equal to a. 0 minus -3 is +3. And 0 minus 3 is -3. Now we simplify the right side by multiplying all of those terms together. So -9 is equal to a times 3 times -3 is -9a. And now we solve for a by dividing both sides by -9. So a is equal to +1. So to write that equation, we have y equals, a is 1, so we don't have to write the 1, x plus 3, and x minus 3. That is in factored form. Slope-intercept form is y equals ax squared plus bx plus c. So to write it in factored form, all you need to do is multiply x plus 3 times x minus 3 and simplify. So the way we multiply is by using distributive property. Distributive property states whatever is in the first parenthesis, you multiply it by everything in the second parenthesis. So that means we have to multiply x times x, which is x squared, x times -3x, which is -3x, 3x times x, which is +3x, and 3x times -3, which is -9. Combine your like terms in the middle. -3x plus 3x is 0. So in standard form, it's y equals x squared minus 9. So this is our 2 answers for this problem. Okay, let's move on to question 2. It's a graph, so I printed it out. All right, identify the y-intercept. When anything tells you to find the c or to find the y-intercept, so on your relearning, it's going to tell you y equals ax squared plus bx plus c. It's going to ask, what is the value of c? The value of c is just the y-intercept. You're just looking for the y-intercept. So you're going to look at your graph and see where it crosses the y-axis. In this case, it crosses the y-axis at this point right here. So the y-intercept of this one is -18. And that's what you have to do on your problem as well. Okay, let's move on to question 3. In a petri dish, there is a drop of water containing some bacteria. The number of bacteria in the dish over time can be modeled by the function b of t is equal to 300 times 1.85 to the T power, where T is measured in hours and B is measured in millions of bacteria. How much how much bacteria was in the dish at the beginning? So the beginning is a keyword. The beginning, that means that time is equal to 0. So all you have to do is replace the T with 0. So let's go ahead and evaluate that and see what we get. So we have B, instead of T, it's going to be 0, equals 300 times 1.85 to the T power, which is 0. This should be pretty straightforward for you to solve. You should not even need a calculator. The 300 order of operation states we do exponents before multiplication. So 1.85 to the 0 power, you need to know anything to the power of 0 is 1. So that changes into a 1. And then all you need to do is multiply 300 times 1, which is just 300. Which is just 300. Okay, something's happening with my camera. Let me figure it out. Okay, so 300 times 1, 300. So my answer is 300. So whenever you see the word beginning, anything like that, initial, the start, you replace the variable with 0 and then solve. And then simplify, I should say. Okay, let's move on to question 4. Okay, let's do number 4. Write an equation of the given graph. So it is an exponential function. So we know our exponent will be in the, our x will be in the exponent spot. First, let's get a table of values to help us kind of create, so we can kind of see what's going on. We have our x and our y. And our x, when our x is 0, our y is -1. When our x is 1, our y is also 1. And when our x is 2, our y is 7. Okay, so we're gonna use that information and hopefully make an equation. So we know it's gonna be y equals, we're gonna have some variable here. I'm just gonna use the letter B to represent it, to the x power. And then something, it looks like something else is happening too. So we know it's increasing at the very least. As x increases, y also increases. So let's see. When we have y equals, we don't know what this number is, but anything to the power 0, we know is 1. So y equals 1. To get my answer of -1, that means I need to subtract 2, because 1 minus 2 will give me -1. So I know I need a -2 at the end. So now we have y equals, let's try it with a 1. So b to the 1 power -2. So let's just kind of think about that. What do I need the b to be in order for it to equal 1? I need it to be larger than the number 2, so it'll be a positive. So b should have to be 3. 3 minus 2 equals 1. And that's true. Okay, so now with our last one, we should be able to prove that it's correct. So y equals 3 to the 2nd power -2. That should equal 7. Let's see if we get that. 7 equals 3 squared is 9 minus 2, which is 7. Okay, so we have created our exponential equation. So y equals 3 to the power of x minus 2. So it's a lot of guessing and checking, but eventually you will get there. Okay, let's go on to question 5. The table below shows the radioactivity level of a substance after the time t in seconds. What is the average rate of change in radioactivity level over the interval 1 less than or equal to t less than or equal to 3. So average rate of change is just a fancy way of saying slope. We use rate of change when the particular item is not linear. Slope is for lines. Rate of change is for an interval over something that is not linear. Okay, so it tells us what we're doing, 1 and 3. So these are our two quantities of interest, and we're just going to find the slope of using those 2 points. All right, to find the slope, use the slope formula, which is y2 minus y1 over x2 minus x1. This is my x, this is my y. We subtract the x's on the bottom, we subtract the y's on top, and then we divide. All right, let's start with our y's. So we have 2.5 minus 10 on top, and on the bottom, we have 3 minus 1. We simplify that, and then we see which answer matches. On the bottom, 3 minus 1 is 2. On the top, we have 2.5 minus 10, which is negative 2.5 minus 10, negative 7.5. And then we divide that. So negative 7.5 divided by 2, negative 3.75. So this is the answer. Okay, let's move on to question 6. Which function has the largest y-intercept? The word largest means greatest, the biggest one. To find the y-intercept, that's when your x is equal to 0. So what you have to do is find where all the x's are equal to 0. For this one, we just have to replace the x with 0. So let's do that. So f of x, instead of x at 0, equal to negative 4x, which is 0, minus 1. Negative 4 times 0 is 0. And then you're just doing 0 minus 1, which is negative 1. So this first one is negative 1. We want the largest. Okay, let's move to the second one. Remember, to find the y-intercept is where x is equal to 0. We find where x is 0, and that is our y-intercept, which is 2. So far, number 2 is leading. Okay, for number 3, same thing. Replace the x with 0. The absolute value of 0 is just 0. 0 plus 3 is 3. Okay, now this one is leading. 3 is higher than 2. To find it on a graph is where it crosses the y-axis. It looks like it crosses the y-axis here, which is a 1. So number 3 is the largest y-intercept because it has a y-intercept of the number 3. Perfect. Let's move on to question 7. The Jameson family kept a log of the distance they traveled during the trip, as represented by the graph below. During which interval was the average speed the greatest? So it wants to know at which intervals of times was the family going the fastest. So we have some options. The first hour to the second hour, so here to here. The second hour to the fourth hour. So the second to the fourth. The next option is the 6th to the 8th. So here to here. And the 8th to the 10th, which is here to here. So we're going to see which section of their trip was they traveling at the fastest speed. So all we need to do is do the slope for each one of these little pieces. So for the first one, we have 110 minus 40 over 2 minus 1. The second one, we have 180 minus 110 over 4 minus 2. Next, we have 230 minus 180 over 6 minus 4. And last, we have 390 minus, oh, did I skip one? That's it. We have 110 to 40, and then our second one is 180 to 110. Okay. Our next one should be 6 to 8. So I just went the wrong way. So 6 to 8, which is 6 to 8 is 230 minus 350 over 6 minus 8. And then the last one is 8 to 10, which is 350 minus 390 over 8 minus 10. Okay, always double check your work. Okay, so now we'll simplify all of these. Okay, option 1 is on the bottom of 1. On top, we have 110 minus 40. Which is 70. So this one is 70. Our next one is 180 minus 110. That's 70 over 2. So that's 35. Our next one is 230 minus 350. 230 minus 350. And that's over negative 2, which is 60. And then our last one is 350 minus 390 over negative 2, which is just 20. So the greatest was option A, first to the second hour. All right, that's it. Number 8, which one has the greatest slope? So you're going to find the slope of the table, you're going to find the slope of the line, and tell me which slope is the greatest. Like we've talked about earlier, to find the slope of a table, you just pick 2 points and count the right and use the slope formula. It doesn't matter what 2 you use, it truly doesn't. I'm going to use the last 2, these 2. So we have 4 minus 4.25 over 2 minus 1. On top, negative 0.25 divided by 1, which is negative 0.25. So that's the slope of the table. Now let's find the slope of the line. Slope of the line, you just pick 2 points and count your rise over run. So your rise is actually going down. So it's down 1, 2, 3. That's negative 3 over 1, 2. Divide that. Negative 3 divided by 2 is negative 1.5. So the table has the greatest slope because it's closest to 0. All right, question 9. So your last question on your relearning, or second to last question, I should say, is about identifying things that are linear versus nonlinear. All right, so if something is linear, the equation will look like this. Y equals mx plus b. So y equals 3x plus 5, something like that. Your x will not have an exponent, and it will not be in the exponent spot. That's what makes it linear. If it's graphed, it will make a line. And if it's in a table, the y will increase or decrease at a steady rate. So the y's are increasing by 2 each time. So that's what makes it linear. Non-linear is everything else. So anything with a squared, anything with your exponent being your x being the exponent is nonlinear. Anything that is not, the graph will be a parabola. a V shape, a J shape, a squiggly line, doesn't really matter. It won't be straight, and the table will not grow or decay at a consistent rate. So these will not be consistent. So that's what you're looking for that particular question. All right, good luck on your relearning.